Okay, in this presentation we're going to look at the random number generation. So it is desired to simulate an observation of the random variable x with the probability density function f of x equals 1 over k, where k is on the interval, x is on the interval between 0 and k. So you might actually notice that that is a uniform distribution, but not from 0 to 1, it's from 0 to k. So it's uniform 0 to k. Now, not 0 to 1, okay? So it's not this uniform distribution, okay? So it could be 0 to 1.5, okay? Or 0 to 10 or something like that. A random number r is generated from the uniform distribution over the support 0, 1, okay? So we're going to use our standard procedure for generating a uniform random variable, an observation for the uniform distribution. Now, the following values are then calculated. x1 equals r times k, x2 equals k times 1 minus r. Okay. Now remember, k is some constant here. Okay. And x3 equals r divided by k. Okay. State with reason which of the above values are valid simulated observations of x. So, x is a continuous uniform distribution over this interval 0 to k. So, okay. So the sample value r in the interval 0 to 1, for argument's sake, let's say k is equal to 6 and r is equal to 0.4. That means x1 lies in the interval 0 to k. Okay. So is that clear, I should say? So essentially, k is a constant. Okay. And what we're going to do is multiply it by r, and r is going to be less than 1. Okay. So that means r times k is going to be less than k. My pen slipped there, so I have to just do a quick restart there. So r times k is going to be less than k. And also what I should say is that r times k is also going to be greater than 0 in each instance. Okay, because r is going to be greater than 0, at least. Greater or equal to 0. That would be a better way of putting it. So that means that our simulated value is going to be in this interval here. Okay, this is the key thing really, this part here. Our simulated values, do they lie in that range? Okay, and only in that range. They can't be less than 0, they can't be greater than k. So in this case, x1 is fine. Okay, so that's a valid that is a valid simulated value for x. Now, likewise, if we're 1 minus r actually works in the same way. And in fact, this is the sort of thing about these values sampled from the uniform distribution between 0 and 1, is that r can be interchanged with 1 minus r without any loss of generality. Essentially, 1 minus r can be characterized in the same way. It has a minimum value of 0 and a maximum value of 1, so it essentially has the same characteristics as r. So for exactly the precise same reasons, we have 1 minus r, and that is some value between 0 and 1, okay? And if we multiply that by k, what's going to happen is that lies also in the range of values 0 to k. So x2 is also valid, okay? x1 and x2 are both valid. So moving on to x3, okay? 1 over r. Okay, let's just go back and check what that is. R times k. Sorry, it's r divided by k. Now k is some constant here. Okay, so is this a possible value, r over k? So let's just consider this out. R over k. Now k is some constant. Okay, so what is the maximum possible value of r over k? Well, I mean, it could be greater than equal to 0. So from that point of view, it's fine. But the maximum possible value is 1 over k. Okay? Because the maximum possible value of r is 1. Okay? So that really means that that does not fit the range properly that we need. Okay? So in this instance, 1 over k can be 1 to infinity essentially, or 0 to infinity. It's not bounded by k, which is the key thing, so it doesn't fit the interval properly. So that means that x3 is not a valid way of generating values of x. Okay, it's not, doesn't do the job. So I just rubbed some stuff out there on a pause. It doesn't fit with that interval, so x3 is not valid. So yes, yes, but no. Okay? So state with reason which of the above values are valid simulated observations of x. Okay. So we'll leave it there.